YouTube live broadcast. Just tell them I'll be a bit late because I now explaining something, stuff that they would not get if they're at home. It's good for them. Alright. Lectures. Let me just open up this. Alright. See if I get my camera running here.
Recording in progress.
Right, chat participants. Video is on. That's okay. I'm okay with that too. And audio. Make sure my audio is picking up. All right, cool. It's picking up through the array, but it's great. Right. Let me just get. All right, I just need to get the link for the stream. I think you guys can get it on my. If you subscribe, you'll get it. But I'll still post the link here. Right, supposed to be getting the stream. All right, folks. Good afternoon. Can you guys hear me out there? Yeah, I'm unmuted. So, oh, wonderful. Nice. Thank you. All right. So let me see. Okay, good. So I'm streaming is good. That is good. All right, we're good. Right. So, for those who are in here face to face, I talked about the assignment. So if you want to get more info, you had to come in class, or you could talk to those who came to class, right? Oh, sorry. Let me just hand this out here. Going there. Yeah, just keep it to the front and or pass it there, top table, right? All right, so what we're looking at is implementing IPv6 routing. So this is the last part of the routing piece, and we could extend this into the inter-VLAN routing, which I'll do in the lab on Saturday. So I'm going to take, the idea is that I'm going to take the lab, the shadow networks to the network which we normally do in Packet Tracer, and actually set up inter-VLAN routing between those. So in IPv6, so that's what we did. So I think I will see if I could do the V4 and the V6, and I could show you that, hey, you know, you can actually do V4 and V6 on these sub-interfaces, and they will work in that regard. So that's what we're going to do. Let me just move the, all right, thanks. Right now, there's a 7.1.1, which kind of became, it was kind of 3 point something some weeks ago. I put up IPv6 stuff in 3 point something. In configuring IPv6 on the interfaces, but I think I'm going to leave that there, IPv6 on the interface, and leave that there, and I'll just leave it as 7.1.2. I wouldn't change this. That'll just be 7.12 and 7.3. Right, we know about the limitations, configure routes, and troubleshoot various static routes. I'll just forego the quick quiz. Right, so just read all this from the text. I think, yeah, I had the text as well. So the default, it should always include a next hop IP address. So that's the thing about IPv6. It must include a next hop IPv6 address. In normal routes, yeah, if you guys see the chop out here, just try to follow on the stream, right? Zoom and yeah, the stream and Zoom will have the full share. So it should always include an XUP IPv6 address. Normally, we would end up putting what we call interface or interface address, or outgoing interface as well. But in most cases, we don't do that now with IPv6. It must be an XUP, and we'll see how to do that. Right, the router cannot successfully forward using this route if using only the outgoing interface. Right, so it's not going to allow you to do that. It should be one of these styles. You could look at the NextHop global unicast address. So there's different ways of the NextHop. or unique local address only. You could do both the outgoing interface and next up global unicast, or refer to both the outgoing interface and the next up local link. So you'll notice something new. This is something called local link address. All right, so we know about global unicast, and then you have the your local link interface. So there's actually multiple combinations with IPv6 which you could do. And in most cases, I know a lot of designs and stuff use the link local address, which is a FE80 colon whatever it is. That's the link local. For me personally, I think the problem with using those is that if you have to change your routes or your static routes, that could change based on the device, could change out. And if the device changes out, the link local could change. And if that changes, then you're going to have a problem. So I would rather use the global unicast addresses in most of my cases of NextHop. And in your design, you'll always have some form of global unicast addresses being used. You can set up an entire network with just link local addresses, but that'll just be router hopping up to router to router to router. It'll work. The only problem is that you're going to end up, that's just moving around. It's just difficult to manage traffic and flow. The cool way of using link local is the dynamic routing protocols. Let me just put DRP. The dynamic routing protocols might be able to use your link local and set it up and say, okay, well, I have link local, I could use that. And so that's more for they to use, and you don't have to use that. So this is network detail for static routes. So in this case, in this example here, we have R1's route to the subnet to the right side of the figure. So anytime you have packets designated to this subnet, they use this global unicast address. It's just like IPv4. So this is the interface that is set up here on R3. And when you set the IP route command, you say, hey, use that address on the other side. Yeah, you gotta chop out again. All right, so it says use that address on R3. If you want to get to this network, use that address on R3. If you want to go the other way around, right, you use the address on this side, which is this network address. So if R3 needs to, anything on the right-hand side wants to get across here, right, you must use this address on that interface of R1. And that's basically how it works there. Right? And when you look at it, this is the command that you use there. So the first command is on router R1, listing R3's global unicast address. That's what you're going to use. And like I said, they're using a global unicast. You need to work with, manipulate, and plan out, right? Link local is not so much because you don't know what could happen. So we're actually using the global unicast address of R3. And that's it, IPv6 route, just like IP route, your destination network, and then your next uplink here. Right, that's essentially it. We just can manipulate it and add more parameters later on. For router 3 is the other way around, right? IPv6 route, destination network, and then you can see look at that, they actually put the interface too. In my case, I'm not going to ask for interface. You could put it in if you want, but you must put in your next up address here. So that's that interface, and you can see the link all the way to the other side. So that's simply how it is with routing. Right. So the default route static default route. So this is I did not do that in the IPv4 lab, but it's in the lab. I just didn't actually do it in the lab itself. So you guys could check that out. What is the default route? That is almost like, I think it was the inter-VLAN routing section. It was before the inter-VLAN routing. So before I started inter-VLAN routing, I was doing routing. And this was with IT network, ISP, and stuff like that. And I was telling it, hey, how to get out. Actually, no, which one I did first? The inter-VLAN first? That looked like a fishbone. Router down and then on the side. That was first, or did I do it with the IT routing? You can't remember? Yeah, I did both, so I just can't remember which I did first, but both of them I did not complete. I chopped short in each of those. So I'm trying to figure out which I did first. Can't remember. That's okay. So that's in the lab. So what happened is that there was a default route. So it come to a point where we wanted to route like all the traffic instead of routing all the traffic. And we did that. We had to type google.com. How to get to google.com, we actually had to put IP route to google.com or the network google.com, and you had to go through this hop. And then you do an next one for next network. But the thing is, we don't want to be typing that every single route we want to get out to the internet, we have to type that out. So we say, well, if it doesn't find a network, or network is not in our local network, use a default route. And essentially it's basically quad 0, 4 zeros. So it's actually, I can write that down here. So IPv4, so V4 will be IP route, right? And it's simple. 1, 2, 3, 4. So that's the default, the network you want to get to, which is any network. And then the mask is 1, 2, 3, 4, which means you're applying it any size, right? And then you have the next hop IP. Right? Right, so this is the IPv4 default route. Right, so the command is IP route, quad 0, next up IP. And that's what it is you're using an IPv4 default route. That would have been in the lab. So you just go through lab, you're going to pick that up. And this is something that you might have to set up and configure in a group project. You might see it in the exam as well. Right, so the default, right, so the static default route. So in this example, what it's showing is that we have a case of 2 branch offices. And the thing about this is that these offices are behind that is your private network, right? Right, so behind that is your home network or whichever private network, PCs or whatever it is. And the thing about it is that you want to set up a route to say, okay, well, I want to send everything else, everything already covered behind, but I want to see anything else I want to go to the internet. Or for that matter, I want everything else to go to my core, including internet traffic. Right? So what they do, they put this default route command in here, both of them, where in this B2 router and B1 router, when we do the IP route command, we actually put the destination and then the mask. And basically it's just this. This is both a combination of both. The destination, colon, and then the prefix, which is zeros, is a /0. Right? So it actually, that's the shortest of all. So you see, let me go back. So all this quad 0 and all that for IPv6 is just shrunk down to just this. All right, let me just raise, I'm going to do the tutorial. Right, IPv6 route, and that's it. And then, well, they put the interface, but if you know the IPv6 address, that will be these guys here, this one here, or this one here. Right, so that they put the interface, but I put because it's a WAN link, they could afford to put the interface because they should not have any other PC here, any other device or router between this WAN link. Right, so they did that, and that's basically it. That's a default route that goes out to the internet. And when you set up your PC, your default gateway, that is what is setting up. To get anything else goes out through the default gateway. So if it doesn't match all your IPv4s or IPv6 addresses in your internal network, it then goes to your default gateway. Hopefully, your default gateway will be able to take you out to the internet. If you don't have internet access in your home, well, then it's just going to say destination unreachable. And that's it, the gateway can't forward, and then that's it, you're out. Once you get that understanding, it's very easy to take like a Linux machine and create that as a default gateway and let it forward traffic out to the internet. It could hook up to like your hotspot, your device, and you can actually share your entire home network through that hotspot device so that everybody can go out to the internet like that if you need to. Right, this is a static route here. So when you do the show IPv6 route static, or even if you take up the word static, you're going to get this entry coming up here, an S:/0. And then you have some metrics and administrative distances happening here. Right, so it's, and this is of course via directly connected. So this is the saying that the static route. In our, in IPv4, you might see the quad zeros 0.0.0 and then the interface. So that's IPv4. Right, so that's the default route. And now we have something called a static IPv6 host route. In most cases, we don't really need to do that here. We just point it to the network, but a host route is basically, remember how you set up, when you configure an interface. Let me see if I can get the IP, if I have it somewhere here. Nope. No, they won't have any, I don't have any output command showing it there. Right? So what they do, instead of, we actually, the exact host is all the bits. So as we go along our bit matching, so let's say you have a 192.168.5.10 or 5.0 or 5.0. Your mask would be 255.2525.0, right? So let's put an example up here. So if it's just 192.168.5.0 as an example, the mask could be 255.255.255.0. Now, that is IPv4. The equivalent mask will be not the mask, but the prefix, right? This is equivalent to like a /24, right? So in IPv6, it will be like closer to like a /8, like what we're doing in the assignment would be /8 here, something like that. Erase that, right? Right? In the IPv6, maybe something like /8. Now, the more you increase the bit size, let's say we go 81, and we keep going up to like 89, let's say 120, and we keep going up to, the more bits you keep using in your prefix, is the smaller the network. The more bits, and you keep going that, the more you keep going, right, that 120, if you keep going around, and you go up, the largest amount of bits it could go with is 128, right? That's the most in IPv6, and IPv4, the most you could go is /32. So, and you'll see it. Remember when I did IP route last week in the lab, I do a show IP route. You'll notice that there's some directly connected routes where you have the actual IP address of the interface set, and there's a /32. So that's literally the actual IP address of that device or that interface. And all bits means whenever you see full /32 or /128, it means that is a host address, and the mask is telling you that is a host address. And that's what you're seeing down here. So, and let me tell you, they call it host routes, but consider it just a route to a single device. It's not even to a network anymore, just a single device. And that's what it is down here. Right? So this is literally a specific device here. And of course, you have to fill in all the values, right? All these bit values. So it's not like any ::0 at the end. It's going to be some value all the way down to the end because it has to be exact bit match. Right? So if you put 20 at the end, it will actually be a PC with 20 at the end. It's not going to be 2 and then anything else after that. If you do try to put something, it will give a problem. Right? And interesting enough, look at this. They put the next up interface, and then they end up putting the link local address. You'll note like FE80 link local address. Now, that's the thing that I don't like about it, is that this value could change. I'm going to put change in question mark. Right? The reason why it could change is because this is very specific to the equipment that you're working on. And so in this example, this might be the link local address. When I move to another GNS tree environment or yours or somebody else, that could change. And that is the risk that you have. So that's why I don't like using the link local. Right? And look at down here, the same thing. I think it was, no, I can't believe that happened there. Right? Same thing here, 22. And now they actually put just they put the actual next up unicast, global unicast, right? So they put the global unicast. So it works for both. Let's see my spelling there. I understand what I spell there. Right, and you'll notice, let me see. Right, so they put the same address here too, 128 and there. So I think it might enter both entries on the table, or it might remove one entry. I think it might keep both entries. You could actually experiment and check this out. Right, now we have something called floating static IPv6 routes. Now it also happens in IPv4. Right, this is when a static route competes with other static routes or routes learned by routing protocols. So next week when we start to do RIP and all these things, you'll see how RIP will start to add routing traffic on the routing table. And that can actually override your static routes, or vice versa. This is what's going to happen. You get floating static routes being formed, and these routes are to the same destination network. So that is the main reason why they will end up saying floating static. You could call it like a backup route, or there's multiple routes to the same destination, right? Which means that your network address that you're going to is the same for both of them, or all of them. I'll show you what's happening here. So this is an example here. So this is a floating static route to key subnet. I'll just do 111.7/7/64. So that's this subnet in question here. And the thing about it is that OSPF, and this could happen. When you're designing a network, it could be the same thing. Could be in a group project, same thing as well. You build out your network and look at that. You end up having OSPF learning that to get to this network behind, it goes through R2. And it gets to there. And then to get to the same network, in here, you set it to go through R3. So this is static at the bottom here. So this is static, what you as the administrator typed up at the command line. And this is a command on the R1 router, right? This command is on the R1 and OSPF is on the R1. So this is what is done on R1 router. It actually have two sets of routes. One it learned via dynamic routing protocol, OSPF, and one that you as the administrator set, which is static. So it's going to have two of them to the same network. The question is which one is going to pick. And what's going to happen, let me see if I have, right. So which one is going to pick? iOS considers the static routes, right, better than the OSPF learned route. That is a feature, default feature of iOS. So that's why you have to understand that. Some of the Cisco exams do come up with, okay, which is the best path to take? And you have to now see that, hey, it could be the administrative distance. They might give you a question just like this and say, okay, which is the path I will take? And question A will say, okay, answer A will be gig 00 interface, gig S0001 interface. I will say, okay, it goes to router, maybe, maybe say pick 2. So they might say, okay, it might go through the MPLS link, or they might say, okay, administrative distance is this. So they will give you different options. But the thing about it is that the administrative distance will determine which is the one to pick over for these routes. And what's going to happen? iOS is going to consider static better than OSPF. And the reason why is that Cisco is saying that the network engineer who entered the commands on it is supposed to know what's going on. They are the intelligence of the design, and they put that in. But engineers can make mistakes. So I will talk about that just now. Right? So what's going to happen is that a static route will be is over the slower part. So this is a WAN link here. WAN serial. What in the world? Let me just change that. Let me just erase and call it serial. That's a slow serial actually. Right, so what's going to happen is it's actually going to pick up your slow serial link as the default route, and all your traffic is going to go through there. While you have a nice gigabit Ethernet link going through Ethernet over MPLS to the router, and you lost all that nice bandwidth that you're paying a lot of money for, you're not using that, right? As a matter of fact, that's what we do for our campus network. We have multiple links to the ISPs, and before we have advanced BGP or border gateway protocol doing the load balancing for us, we say, okay, this traffic that is to the web pages goes through this slower link because we dedicate that for our internet, for our websites and our MyLearn in those days. And then they say, okay, for those who want internet and streaming and Zoom, all that, we send all that traffic out through the bigger link. And we actually set up the parts and multi-parts to say, okay, this part, everybody going through here, you use this link. Everything else, you're going through this bigger link. And that's basically what kind of happened here. A little different, But that's kind of like what we set up here. So that way you're tailoring the route. So the thing about it is that static is administrative distance of 1, while OSPF learned route is an administrative distance of 110. So 110 is less than, one is less than 110. So it'll actually use the static route over 110. Static route over the OSPF learn route, which is what we don't want. So what we're going to do, right, it'll use the lower part to reach the subnet, which is not the intended design. We wanted to use the higher speed link. So what we need to do, we have to change administrative distance and use a floating static route. So what's going to happen, right? So it's going to preferentially use this. So this is going to be number 1, first preference. So what we're going to do, we're going to implement a floating static route. We're going to override the default administrative distance on the static route, making the value larger than the default administrative distance routing protocols. So this is the example of the command IP. So this is where you have to understand the dynamic routing protocols in play. So we know OSPF in this case is 110. So we need to set our administrative distance larger than 110. Right? This is for the static. So this is the command here, IPv6 route to this network. This is the next up address, and this is the most important, the administrative distance of 130. Right? Now, we could do other values like 120, but the thing about it is 120 is already taken up by another routing protocol, which is RIP, which is what we're going to do next week. So that's why we shouldn't really use 120, because now the static route is going to compete against RIP. So if RIP learned a route and static learned a route, well, then it's going to pick, well, we don't know which one. It might actually try to go through both, which happens. When you test the, when I go to the OSPF labs later on, it'll be cool. I'm actually going to have like 4 routers on the lab, at least 4 routers, and you're going to see packets going through one set of routers and packets going through the other set of routers, because the speed links are the same and the distances are the same. So both are technically the same distance, and it load balances. So that's what happens when you have the same administrative distance or the same costs going across. It's going to go through both links, which in essence makes sense, because bandwidth is good, the latency is good, then the traffic flow is good. Why would you need to go on stick to one? So you don't have to stick to, you could just stick to one, you could both. But in this case, we wanted to use the faster link all the time. So we started with an administrative distance 130, larger than the OSPF 110. Right, so this is the command here. You could do show IP route static, and as you can see, in this example, the value has increased. And if you do show IP route, the distance is 130, and it's going to end up forcing it to go through primary link now as the number 1 link, and then this guy will be backup. Right, I'm not seeing the other value of OSPF here. I find they should have, I think they did static, but they should have done both, and show you what OSPF looks like and what the other route looks like. The other route is still there. In the event that the OSPF link goes down, guess what? The link goes down, that entry is out the routing table, and the only one remaining will be the static route, and it will then traffic will flow. So in this way, in essence, you set up a load balancing setup at this point. And I'm just going to show you the administrative distances, and I'm going to go through a few of them so you guys can take a look at it. So this is the default administrative distances for Cisco. All right, so I'm going to write on Cisco. So connected routes are 0. So then you remember, connected routes are basically putting the IP address on the interface, IPv6 or IPv4 address on the interface. That is a connected route. And in most cases, it should, in most technology, Huawei and stuff, will remain 0, because a connected route is the only way you could get access out other than using interface broadcast or out in the interface. So this is supposed to be most accurate information that is set. That's why they put it as 0. You'll note that static route is 1. And this is much about the NDP, we're not worried about that. You have EIGRP. So you see this is 90, which is what we're going to do later on. You have OSPF, which is 110. It's larger than EIGRP. That's a Cisco thing. So this is Cisco. Cisco is very biased here. right? Because they prefer their protocol over OSPF. But that's fine, because if you don't use EIGRP, well, you're not going to see an administrative distance of 90 anyway, because you're not using it. So that's fine. And that's happening right now. So everybody's using Cisco with OSPF and another vendor routers. So no more EIGRP, that's gone. And they took it out of the syllabus too, so unfortunately. But OSPF is 110, RIP is 120, and RIP is 120. Well, that's Cisco, but RIP is not as efficient as OSPF or EIGRP, so they kind of put it as a lower priority protocol. And an unknown or unbelievable, once it's something like this, is like, okay, we can't get to this network, or don't even bother. So sometimes, this is a trick, if you want to give a network and say, hey, I don't want anybody on my routing table to go anywhere through this network or something like that, I can put the network and put administrative distance at 255, so it will never use that interface there. So if you think somebody set up a plugin and interface and it goes out to the internet, you could always say, okay, and if you can't shut it down, you can do an IP route and say, okay, administrative distance of 255. So in most cases, you will not don't go through here. So it's a nice way to kind of block traffic or filter or DNS, to hold a traffic flow by doing this. So people want to go google.com, and you know the address to google.com, you could put IP route to whatever, 172, whatever, and then you send it to that. And in that way, it just say, okay, go to there, and it would just be a black hole or a kind of route. Or if you want to be very thing, you could actually make it static and black hole it to like invalid next hop, which we will show later. Right. So I'm just going through some more values here. You guys could check out the Cisco website for this. You don't have to know all of this. It's just a few: EIGRP, RIP, OSPF, static, and connected. That's the main ones. The others you don't have to worry about too much. Well, except BGP. External BGP is the one. So it's only for the WAN course that you'll deal with BGP coming up here. So we're really concerned about static, connected static, OSPF, EIGRP, RIP, and that's more or less it. Right, so this is Cisco's website. They give more details in it. Let me go to the next page. Other vendors like Huawei will have their own. Remember, they build their equipment. They set what is the administrative distance. Not basically, it's not something that is a rule out there. They set it. So look what's happening. Huawei, and I'm going to keep this way. This is external preferences, and these are internal preferences. So let me go to the internal. So internal is literally inside the internal routing protocols. So it's internal network, right? So BGP is supposed to be external. Well, I don't know why they put that there. So they kill that. I think it's IGBGP. They even kill that. Look at that. Right. So BGP is supposed to be external routing protocols. But so you could notice that I don't know why they put it as just case. Because eBGP and IBGP now have values that is actually not 255. But that's all right. You notice OSPF is small. Static is 60. So look what's happening here. You notice there's no EIGRP, right? Right, where's the EIGRP? It's not there because that's Cisco. EIGRP is part of Cisco. This is Huawei, a different product, a vendor. So they're going to put protocols that are more open. So again, RIP is there, and you look at that. They put it as 100, not 120, as we saw it in Cisco. Static is 60 versus the one that we know in Cisco. So they don't, and look at that, they put OSPF smaller. So what's happening is that Huawei is trusting OSPF learned routes over static, right? Because OSPF is going to do the calculations and say, hey, the bandwidth is good, the link is good, and all of that. And say, okay, this is the best route. And that's why they prefer OSPF over static, because static routes, you could always have the human factor where you type the wrong command, the wrong route, and the wrong metrics or the wrong address, and it could be a wrong thing. What is learned by OSPF is close to not close to the real correct value, but it's close enough. It may, in most cases, it will be correct because it's learning between all of them. The only way you can actually get the wrong information. OSPF is do like route poisoning, where you actually fake a route and tell it propagate. And if you pick that up, then you have to start doing authentication, which we're not going to cover in the course. But, right? And all these guys, static is 6 day and stuff like that. Just another summary table here showing you all the different, these are different brands here. So Cisco, Juniper, HP, Huawei, and they compare the two. So static routes, you see 1, 5, HP. Look at HP and Cisco about the same. I think they do put Dell here, but Dell creates stuff is similar. RIP is changing. Look, 120, 100, 100, 100. Right, ERGR PLC is not applicable for these other guys as expected. And then OSPF now we have 110, but the rest of them are smaller, 110 and 10. Right, internal and then external. Right, so you could see the different vendors have different administrative distances based on equipment. So just something to get you know when you start to configure. Right, troubleshooting static IPv6 routes. Right, so there are two perspectives. The route is in the routing table, but is incorrect. So basically, you as the admin type in the static IP route incorrectly. And that is why OSPF would have been the better one to do it. Or the route is not in the routing table. So this is the thing. And this is where you have to do your check. So once the route is in the routing table, the router will try to match destination source, destination IPs with that. It's going to match or try to match. If it's not in the routing table, well then router is not there. It's not going to do any matching. So the objective of most of you as static routes or dynamic routing protocols, the objective is to get your calculations out and then place those entries in the routing table. Right? That is the most important data structure, is to place these routes on the routing table so that it will actually do the work at the end of the day. Simplistic work, telling you where to get to this network is how to get to it. But that is important. That's important to get it to there. Right? So incorrect static routes, so you have different things. Incorrect outgoing interface. You have incorrect next hop address. And the funny thing is that you can type in the wrong in next hop address. And you can do it in the assignment or the group project, for instance, and you're saying, hey, why is this not working? Right? Or for that matter, incorrect prefix length. So it's almost like, this reminds me of undergrad. Not me as a TA, as when we was marking undergrad scripts. And a student will come and say, hey, how come my assignment not working? How much time not working? They go as Java they're doing, they click compile and no errors. And they say, well, and then they say, well, why not working? Because it's showing no errors. But I told them, well, because syntax-wise, it's okay, right? Syntax-wise, if your route entries are okay, the logic behind it is saying, is it really doing what it's supposed to do? Is the if statement in the right location? Are you actually performing the right condition checks? Are you moving data from one point to another point or manipulating data to get the results you want? That is the questions you ask. So compiling means syntax is correct, but execution-wise, logic is not. And that is what is happening. All these issues are more logic issues, just like in debugging your program or software programs and all those things. Right? So it passes the syntax, like I said, checks. It places it into the running config file. And if there's no other issues, it then puts the route in the routing table. So you'll notice two things happen here. One, it puts it in the running config. So when you do a show running config, that's the entry you put in with no errors. It goes in there. That's one. Two, and that's the reason why you put the show IP route, because it could be in the running config file, but it might not be in the routing table. And that's why you have to do show IP route. So that's what people kind of misunderstand and say, okay, getting the running config is everything. It's not everything. You have to run the other commands to see what the device is seeing in that state at that point in time. And that's why I have a whole bunch of commands. You guys would have seen it in the forum, in the assignment one. One of the answers say, hey, these are to help you out. A spreadsheet to fill out to guide you on doing the mapping on the switches. And then a next thing, which is a text file showing you all the commands you can run on the equipment. Now, most will work, others will throw an error, but that's fine. That's because of the version of iOS and the type of device and all those things. So you might see some things that were meant for switches are being run, and it's going to show errors because it's on a router running, and then those that are meant for routers, you're throwing it on a switch and then you get errors. But that's fine, because let it throw an error, it kind of make it a holistic, just copy and paste it into the party terminal and let it throw the output for you. And the cool thing about it is that there's a command I put on the top called terminal length space 0. That actually does not tell you press any key to continue. The more command at the bottom of the console, it's telling you, okay, forget that, just dump everything to the screen and don't wait for any input. Bad thing is, if it's a lot of stuff, you have to wait a while for it to run through. Good thing as well, you have all the information now that you can sift through or copy to a log file. I do that to copy to a log file. So I don't know why I have not done that. I've built up my config file years ago about that, but I now started to do it more often. In that, anytime I connect a new device or any device for that matter, I copy all those commands and paste it straight in. Some of those commands I wouldn't give you because that's specific to our network, so it's not there. But my command list will contain those specific commands. So I will paste that into the equipment. It'll do a dump of output of all my current state and run in config so I could compare. And then I make my changes. And then along the way I do my double checks. And then I rerun it again. You'll notice there's a clock command, show clock before and after. So that's me time stamping the output. So I show the clock when it started the timestamp and I do a clock at the end of it. So if somebody come and screenshot, an image screenshot, and they say, hey, is this correct? When it was run. Are you sure it was run the right time? Well, look at my borders. My clock borders are telling me it ran at this point, 5 p.m. and it finished at 5:01 p.m. So it ran on that space and time and on this date, and that's it. So you take all that snippet. So the only way to fake that now is to actually try to modify the lines inside, right? But if you have it as is verbatim, that was what the output was at this point in time. So you put the clock into the output. It's a good way to do it in your batch files. Those who are doing scripting and stuff, put the times before and after you execute. So you know when, not because how long it takes to execute. It's for logging purposes to know that, okay, it worked at this point in time. And somebody could review it and say, yeah, it did work. And then this is more for things like forensics investigation, all those things. You put those timestamps in the logs. This is important to do that. Right? So this is a bad accepted IPv6 route example. Right? So I don't know why I don't have one in my diagram. Not here. Right. So this, I should have an example with the diagram just now. So this is the example, IPv6 route, that's fine, right? It'll be accepted, which is valid, 333 and class 64 and next up. In fact, this 2001 could have been anything. It could be 21111 and all ones and it will work, right? But based on the design, it might be correct. So let me see. I don't know why it's there. Hold on. Yeah, they just put an example there, but they put it there to say, okay, how can you tell this is correct? Right? Correct. All right. So they say with a neighboring address of this. Right. And they put, right. So this is what's happening here. So R1 has an address of this, and the neighbor's router is the ::2 at the end. But I put my next up as ::1, which is what? This is R1's address. So we are telling it, go back to the R1's address to get out there. It'll throw an error. When you send a packet, it'll stick, it'll drop. Because it's telling it go to R1, R1 will pick it up, and then it might loop or it might just drop it. So this is, it works, but it would not send, the command will work, but it would not send out any packets. So this is a simple one. So just checking it. Right, so some steps for check for bad IPv6 routes, and this is what you guys would do when you're troubleshooting. Same applies for IPv4. Does it command reference the correct subnet ID, prefix, mask? So that's why you have your whole table. Remember I did my table with showing you the network as the prefix and all those things? That is what this is for, to make sure it matches. You plan that out before. And when you plan it out before, it's easy to write the commands out and then you can execute the commands. So you have your different steps. Plan it out, write your commands for it, and then execute the commands. 3 steps. And then you iterate in between, right? So step 1, right? If using an, all right, this is what you might want to use for the lab exam, right? Right? So as much as you'll want to do the group project, you'll want to use these steps in the lab exam as well. Now, you don't have to memorize these steps so much. Maybe what you should really do is to kind of practice to do your troubleshooting of these steps when you're doing the well, not the assignment, but more the group project or the labs, like this week labs, weekend labs. You're going through that process to see that you're doing everything right. So once you follow those steps, you're gonna apply that in lab exam. All right. If using a next hop IPv6 address, that is a link local address. Well, you see, this is the problem, and that's what I didn't like about link local. Right? Is the link local an address on the correct neighboring router? Well, how can you tell? Is it on your design? You have to actually go on the router and view the IPv6 addresses on the interfaces. Right? It should be an address on another router on a shared link. Well, we don't know. But the point is, that's the problem I hate about this, using link local. But if you design your network properly and using global unicast, you could skip A. Right? Actually, for that matter, right, you could skip step 2, you skip more or less A and B because you're not going to be using the outgoing interface. So you realize a few things. I already skipped out 2 parts of this troubleshooting step, because I decided to use global unicast address. 1 is not a link local, and 2 is not a local outgoing interface. That's the 2 things. So I'm doing that. Look at that. I already skipped out almost a whole step. So then I go straight to step 3. If using an IP address as a global or unique local, or is the address correct unicast address of the neighboring router? So if it's, and that's the thing, if it's a global unicast or unique local address, unique local uses a different it's not like 2000 and something or 3000 and something. That's global unicast. A unique local is I think it's FC something as unique local, but that's fine. In your plan and design, you put those settings out and you configure it on the equipment. You don't have to worry about link local addresses. Link local is created by the device. So that's something out of your control. But you put in your global unicast or unique local. That's something under your control and your configuration. So you plan it out and you do the right thing. That's how it's going to work. So that's why you could skip step 2, because you already do your design is going to make sure you skip step 2. Right? Does the IP route reference the interface on the local router or where the static route is configured? When referencing an outgoing interface. So, step 4, if we don't use outgoing interfaces, we don't have to worry about step 4. Now, your design and troubleshooting, that's fine. You could skip step 2, and skip step 4. But if you're doing like a Cisco exam or something like that, you will have to check it to make sure that those things are the right things, right? So, your design, you could skip 2 and 4. But out there, when you're testing and stuff, you may have to follow all these steps. So just remember, you may ignore step 2, but just remember step 2 and 4 might be important to remember when you're doing those checks, right? Who knows, lab exam might have something like that for you to do. Right, so this is with correct. Let me see how fast I can finish. I'm almost done. Right, so this is, I'll do the next slide on Thursday. This is with neighbor advertisements and all those other things too, right? Correct syntax, but incorrect ideas, right? So this is what is going to happen. So in this case, it'll be wrong prefix, and they're giving you, look at this happening. They actually mirror to the steps that you're diagnosing, right? So step 1 is wrong prefix. So one time this is already incorrect, and this is for your DB8:33, right? So you see here, it's not matching up to this tree here, right? That's this link here. So that's what's happening here, right? So it's a question mark here. Is it the same? No. Right? The next one, wrong neighbor link local. So this is on right, FE80. Now this is right. So that's this guy. So he's trying to compare to this one here. Wrong link local. Now this is the thing. For you to get this link local, you have to actually go in your router and pull that out on equipment and get that. But if you configure it with your design global, that's just this value up here and you're done. So that's what I say. You could use it by, I say avoid using it. If it works, it works. But try to use local unicast, global unicast. And this one here, missing outgoing interface. Now, I don't know why they're saying missing outgoing interface. This should not be an error. This should have worked because it's IPv6 route, network, and then next hop address. So I'm suspecting it's because they're using a link local, and that's the reason why they have to put the outgoing interface once it's link local. So now you have problems there. So I would rather use a global unicast because look, this is matching up FE80:2, but it's not saying, hey, use gig02. This one is the wrong neighbor address. So this is supposed to be not 9:2:1. It's supposed to be ::2. Right? The ::1 is this address. So it'll accept it, but it would not send out the traffic. And then the last one is wrong interface on R1. Right? So this is gig01 is when it's supposed to be gig02. Right? So these are some popular, this is literally all these step examples on this example of where they have problems with. Right? This is just going through all these steps, telling you where the errors are. I wouldn't follow. I just went through all of those. Right? I don't know why we went into more detail here. Right. All right. So this is wrong interface on R1. So that's okay. Let me go to the next slide now. This is where the static route does not appear in the IPv6 routing table. So this is the problem. When this starts to happen, I would say not get scared, but more concerned because the routers is not adding it on the table. It's accepting it, but it's not added. That means it's not something is wrong with something with layer 1 or layer 2 stuff happening there, right? So it does the same for static. For IP route, list that. It must be in an up state. So now you have started to do diagnostics on the layer 2 level. So this is layer 1 and layer 2 diagnostics, right? So you have the global unicast. Next up is not a link. Local must have a route to each next up address. So you have cases where it's not link up. That's the next case. If a route exists and the prefix must have a better low administrative distance. So this is where floating static routes may actually remove it from the table. And that is why your show IP route may not show it at all, or IPv6 or mightn't show it. If you show running config, you might see it, but it's not there. And you have to start to deal with administrative distances. So look at this at the end. All right, so that wraps up this. All right, I'll just skip through. This will be for like the next session, right? NDP neighbor solicitation is the name of it. All right, just summarizing, and let's end of 7.12. You guys could check out all these links here to get more information about what's happening. And as you can see, the text is based on, this is based on these chapters of the text. So whichever one you get, it's kind of like the same chapters. All right, okay. Any questions? Hopefully not, right? Good. As usual, email out into the forum, message on the forum, which somebody got a response about same day or next day. And I think it was the same day in the evening. They got a response in the evening, late in the evening. And emails, I actually had a student email me about GNS3 this today, and I got through responding to them, and they got through with it. Just a quick thing on the forum is that, not the forum, sorry, with the GNS3, if you start all the devices, sometimes the PC, and you try to connect it through the SolarWinds, the PuTTY, sometimes they're throwing an error coming up, and they can't connect it. Sometimes you have to right click and restart the device, like a PC especially, and then you could click reconnect and it'll connect back to the PC. It's kind of bug where it starts up and then it didn't start up properly. I think it's more a GNS3 bug than anything else. But that's where you could do that. Now make sure if it's your PC, make sure you have your commands already recorded and saved, because if you do a restart, there's a chance it may not save and you might lose the config. Now the PC is easy to configure. You just have to v6 and save, and that's basically it. With the gateways, of course. Well, no gateways. Sorry, just IPs. That's all, right? For the routers or the Ether switches, that's where the problem is, because if you reload those guys and you don't save a config, all that is gone. So that's why you type out all the settings you want for each of the configurations you want, and you place that in there. Have it ready so that when it reloads and you lose it, you can just copy from your text file and paste it in the console and let it re-enter. You can't copy and paste. Somebody tried, didn't work? Where? You guys are describing stuff and you screen. Right. Right. So SolarWinds, right? SolarWinds PuTTY does have messed up sometimes. When you right click or open the console, it launches Solar PuTTY, funny looking interface, but then it also launches the PuTTY interface separately. So what you should do is don't close the Solar PuTTY interface, minimize it. It kind of ties it onto the PuTTY. That's the problem when you sell yourself out to another company. GNS3 has a big sponsorship through SolarWinds, and they decide to put their interface and all that stuff. That's the problem, and it kind of buggy. So you do that. The PuTTY comes up, cool. You leave the interface, minimize the SolarWinds PuTTY, and you just do your work from there. And which is good, because for me, I prefer it that way, because you can move you could have like 2-3 windows on one side and then 2 on the other side, and you could work like that. As opposed to one window and you have to click tab. And when you do all multiple windows, you look like a hacker as well, right? So you could do that. I think in PuTTY you could change the colors too, so make a nice little green font, look like the Matrix, and everybody asks what you're doing, and they say hacking, yeah, you're just hacking, right? So that's with that case. I think try back the config, try back the pasting of the commands in there and see in the PuTTY, right? I will try it because you guys say it didn't work, but I've done it before, so it's supposed. And PuTTY allows copy pasting, so that's the reason why. I don't know. What you could do is you could do a snippet video if you want and show it. Move the mouse, right click, just a screen recording, and then it's either turn up in private, unlisted on YouTube, and then send the link to me, and I could check it out if you want to, or something like that. That might be the fastest way to do it. Well, kinda, or phone and just screen record it and turn it on YouTube unlisted, and then send me the link, and I could check it out. But I will try it myself just to see that it's working for me. I don't know. I don't know. I think it's something is up there. Where's that? And you router or the PC? Right. Okay. Good. That's what I asked now. No. Right. So the PC is a kind of funny thing. You could only do one command at a time, not the whole IPv6 that and then IPv4 that, copy and paste. You're supposed to be able to highlight just the IPv6 address, copy that, paste it in there, enter, and it's supposed to work. The IPv4, same thing, copy it, paste it, that alone, enter, and then that's it. And you're done, type save. Enter. Don't good that you bring that up. I wish I could have put it up on the forum so I could explain that. But that's fine. At least I have it here. The forum better, because imagine you trying to go through the video to get an answer for that. So the forum is very specific and structured. So if you could, one of you could post that up saying, hey, you're copy pasting in the PC and it's not working. And I could go through the process and explain what you should do. That'll help out everybody too. So you could do that. And I will go through the same thing with the PuTTY for the switches and show you how it works. So that you could say, okay, this is what you do, it'll work. If it works, take a video and send it and tell everybody. And if no post any forum, hey guys, I got this to work this way. But unfortunately, you'll have the work to show them how you got it there, right? That'd be great if you could. And as a matter of fact, if you get that to work, put it on your blog. Because not much people do that. This is something other people like, and say, I don't like PuTTY, all right. This is how you could use a command line and put it in. So if you do that, that'll be great. Put it on your blog, you put a video to it, or even screenshot the process. That'll be great. But start with the video and tell them, hey, you got it to do work this way, and maybe they could try it out. That's all it is, experimental stuff. All right, so you guys good? All right, nice. I just think I will try later tonight during the week to start to put the forum for you guys to start a group project yourselves in. 3 persons per group. That's what I'm going to put in the notice. And I'm going to create the forum for the group project, and you guys just start to put in your memberships. I'll just do all the table, and then you just have to fill in details. Your group, you don't have to put a group name, but you can put a group name, your members. I do one more thing, members IDs. At the end of the day, find out if you all want to do like your own Excel sheet, and whoever's outside, who's not in a group, then I'll have to put them in their own group at the end as outliers. All right. All right. Cool. Enjoy. I think everybody sign attendance. I didn't. Oh, you come. Oh, you come back. All right. I'm here. All right. So online. Bye, everybody. All right. So